Hello guys, welcome back. So in this video we are going to learn about Huffman coding. Okay, so let's get started. So Huffman coding is used for generating an almost optimal code. Why almost? Because you may get efficiency very close to 100%, but not it may not always be 100%. Okay, so that's why I mentioned almost here. So the next point, the output of Huffman coding algorithm is the variable length code words for encoding source symbols. Okay, so after applying Huffman coding, you get the output as variable length code words. So the third point, in this technique, more common symbols are represented using fewer bits. Okay, so the symbols that occur frequently are coded using fewer bits. Okay, so now let's move ahead. So here I have the algorithm for Huffman coding. So let's see this. Please try to understand. So you'll get the basic idea. So let's see. For each letter, create a tree with single root node and order all trees according to the probability of letter occurrence. So first what we have to do is, for each letter create a tree, okay, and order them in ascending order. Okay, so the minimum one comes first, then the second highest, and so on. Okay, so this is the first step. Then after that, what you have to do is, you have to take the two minimum probability trees and add them together and create one new node as the root, and its sum will be equal to the probabilities of those two trees. Okay, so we have take the two trees T1 and T2 with lowest probabilities P1 and P2 and create a tree with probability in its root equal to P1 and P2 and T1 and T2 as its subtrees. Okay, so you have to take the minimum two probabilities, add them together, and their sum will be their parent, and those two probabilities will be the subtrees. Okay, so this is the meaning. So now what you have to do is associate 0 with each left branch and 1 with each right branch. So you have to assign 0 to the left child and 1 to each right child of the tree. So next, create a unique code word for each letter by traversing the tree from the root to the leaf containing the probability corresponding to this letter and putting all encountered zeros and ones together. So for finding a unique code word for a particular letter, what we have to do is, we have to start from the root and traverse down to the child node and just note the zeros and ones encountered on the way. So that will be your code word for that letter or the symbol. Okay, so let's see an example. So consider the source ABCDE with probabilities 0.35, 0.17, 0.17, 0.16 and 0.15. Okay, so how to construct the tree? Let's see. So we have to first arrange these probabilities in ascending order. So we have 0.15 at the beginning, then 0.16, 0.17, 0.17, 0.35. Okay, so now we have to combine the two minimum probabilities and take their sum. Okay, so we combine these two, 0.15 and 0.16, and make a new node as their parent, and what will it contain? The sum of these two child nodes. Okay, so 0.15 plus 0.16 is 0.31. Okay, in this way you have to combine and create the sum as the new parent. Okay, so now what do we have? We have 0.31, 0.17, 0.17 and 0.35. So now let's take the two next two minimum probabilities from this 4. Okay, so which are the two minimum probabilities here? We have 0.17 and 0.17. So let's combine them together. So we have 0.17 and 0.17. So adding them together, we get 0.34 as the sum. So we make that sum as their parent, and these two will become the subtrees of that sum. Okay, left and right subtree. Okay, so this way we have combined 0.17 and 0.17. So we get the new probabilities 0.31, 0.34 and 0.35. So next, take the two minimum probabilities from these three. We have 0.31 and 0.34 as the minimum probabilities. So what do? We combine them together and create a new parent taking the sum of these two probabilities. So we have 0.31 plus 0.34 equals 0.65. So this sum will become the parent of these two probabilities, and these two will become the subtrees. Okay, so these subtrees also will go together with them as it is. Okay, so now we are remaining with only two probabilities, this 0.65 and 0.35. So we have to combine them together. So what do we get? Thus we get sum as 1, and this 0.65 and 0.35 will become the left and right subtrees of that new sum or the parent. Okay, so see here we get the answer as 1 here. So when you get the answer as 1, your answer is correct. Why? Because always the sum of all the probabilities of a set always equals 1. Okay, so we have constructed the tree. Now we have to assign 0 to all the left subtrees and 1 to all the right subtrees. Okay, so we have a left subtree here, we assign it a 0, here also 0, left subtree here 0, here left subtree 0. So now assign 1 to the right subtrees. So we add 1 here, here and here. Okay, so we have added 0 to all the left subtrees and 1 to all the right subtrees. So now we have to compute the code words for the corresponding source letter. So see here we have 0.15 here. What is the source letter that corresponds to 0.15? Is letter E. Okay, so what is the code word for E? Let's see. We have to traverse from root to the child node, that is E. So we get 0, 0 and 0. Okay, while traversing we have to note down the symbols or the assign values and combine them together. Okay, so we get 0, 0 and 0 for letter E. See here we have got 0, 0, 0 for letter E. Now 0.16 is the probability that corresponds to the letter D. So for D, what do we get? Traverse from root to the D. So we get 0, 0 and 1. So for D we get 0, 0, 1. Next for C we get 0, 1, 0. Okay, so for C we get 0, 1, 0. Now for B we get 0, 1, 1. So for B we get 0, 1, 1, and for A this probability 0.35 corresponds to letter A. So for A we get a 1. Okay, so we get a 1. So see here the highest probability here is 0.35. Okay, that means letter A has the maximum probability among all the other letters. Compared to all the other letters, A has the maximum probability. That's why the length of that code word is less. Okay, so the letter which can occur or occurs more frequently has the lesser code word length. Okay, so now let's move ahead. So now let's compute the efficiency. So we have L average as summation I equals to 1 to n pi into Li. So we substitute pi and Li values. So what do we have? 0.35 into 1. So here see this, for this 0.35 we have got the code word 1. So what is its length? 1, since it contains only one digit. Okay, length is what? The number of digits a particular code word contains. So here the length is 1, here the length is 3, here also 3, 3 and 3. So substitute them in the formula. So we get 0.35 into 1, 0.17 into 3 plus 0.17 into 3 plus 0.16 into 3 plus 0.15 into 3. So the answer is 2.3 bits per letter. So we got our L average. Now compute the entropy. So we have summation I equals to 1 to n negative pi log to the base 2 pi. So substitute pi values here. So first probability negative 0.35 log to the base 2.35, negative 0.17 log to the base 2.17, second probability. Next negative 0.17 log to the base 2.17, third one. Next 0.16 log to the base 2.16, fourth one, and the last one 0.15 log to the base 2.15. Okay, so we get these answers after solving for this individual, and the final answer is 2.23284 bits per letter. Okay, so now the efficiency is h of s divided by L average into 100. So we have 2.23284 divided by L average is 2.3 into 100. So we get an efficiency of 97.08%. Okay, so this way you have to construct the tree, find the code words and find the efficiency. Okay, so I hope it was clear to you. So if you have any doubts, you can ask me in the comment section. So thank you for watching. Keep learning.